Hi, my name is Eliza Lawrence, and today I'll be presenting about the research project I worked on this past summer with funding provided from the Summer Undergraduate Research Fellowship from the Center for Undergraduate Research and Experience at the University of Oregon. My project is titled Mapping Landslides on Prince of Wales Island, Alaska, from 2009 to present day using Planet Labs imagery. My research advisor is Dr. Josh Roering from the Department of Earth Sciences, and I also received advising and support from Dr. Annette Patton from the Sitka Sound Science Center. So to get started, um, my project is based on Prince of Wales Island, which is located in Southeast Alaska. Prince of Wales Island has steep and rugged terrain and also receives high levels of precipitation, typically about 100 inches per year, which make landslides a frequent occurrence. And a landslide is defined as the rapid downslope movement of Earth materials driven by gravity. And one type of landslide is called a debris flow, which is a fast-moving mixture of mud, rocks, and trees. And landslides are of particular concern because they can cause property damage and can also be fatal. And that's because landslides often occur without little warning, and um, debris flows can move very, very fast. And so people can outrun them or get away from them. And these landslides are typically brought on or are triggered because of high amounts of precipitation, and in particular, precipitation that is brought on by atmospheric rivers, which we define as fire hose corridors of large amounts of rain, or just a large amount of rain occurring over a very short interval over a day or so. And the purpose of my research project was to create a catalog of the location and timing of all landslides that have occurred on Prince of Wales Island from 2009 to present day using high resolution Planet Labs satellite imagery. And the purpose or kind of the idea behind this project started because of previous work that both Dr. Roering and Dr. Patton had been involved in. And that was through the Sitka Landslide Dashboard, which was published in 2021. And the Sitka Landslide Dashboard communicates the likelihood of a debris flow at any time based on past landslide conditions and current precipitation levels. And Sitka is another small town located in Southeast Alaska. And so basically how this dashboard works is that anybody can log on to this website. It's called sitkalandslide.org, and you can look and it will tell you what the likelihood of a landslide occurring is. My work is also rooted in other previous work from the United States Forest Service, and in particular, the Tongass National Forest Landslide Inventory. And this is another website that has mapped over 20,000 landslides in Southeast Alaska since 1950. This is an amazing project. Such a large number of landslides have been mapped, which is amazing. But I wanted to kind of fill in the gaps of this project. And in particular, this project uses low spatial and temporal resolution imagery. And so low spatial imagery, that means that each pixel on an image represents 15 meters. And then the temporal aspect of the resolution of the imagery means that images were taken every 10 years, which leaves a lot of gaps in understanding what the timing of these landslides are, and like even what years they occur. And so this imagery that I'm using from Planet Labs has a spatial resolution of about 3 meters, anywhere from 3 to 5 meters. And then images are taken, they say every day. But from my work, I found that we can definitely get clear images that are cloud free about every month. And even in more recent years, every week is better. And so this image down here on the left is of the United States Forest Service landslide inventory for the Tongass National Forest. And basically it includes polygon outlines of landslides that have been identified with the air photos that they've used from 1948 to 1998. And then they've used satellite imagery for the more recent imagery from 1998 to 2020. And so kind of my process for identifying these landslides It begins by using this online website called Planet Explorer. And with that, I can download and create a mosaic of images from the fall of 2009 to 2022 that cover Prince of Wales Island. So basically, I log on to this website and they have images, every satellite image that they've taken, and I can narrow that down to like 1 year. So I've normally set my date range from like August to December of, for example, 2009, and then it'll pop up all of the images from that time period. And a lot of the images aren't very clear because satellite imagery is really heavily affected by like clouds. So if it's a really cloudy day, then the satellite imagery is not going to be very clear because satellites are above the cloud line. So anyway, I take the images from the fall of one particular year and I narrow down so I get like a good mosaic of images that cover the island. And then I input those images into QGIS, which is a open platform QGIS or GIS platform. And then I can visualize them and look. And then I overlay a grid of previous years. Or first I overlay a grid so I can really like methodically go through the whole island and identify what landslides have occurred in each block. And then I also will overlay the previous years of identified slides. So for example, in 2009, there aren't any slides from earlier years. So I'll just identify all the slides that I can see. And then I'll save that layer of polygons that I've outlined of landslides. And then when I repeat steps 1 and 2 for 2010, I'll have the 2010 images, and then I'll input the landslides that have been identified from 2009, and then I'll identify any new landslides. Once I've identified landslides throughout the whole island, I'll then narrow down the timing back on Planet Explorer, which is the online website. And basically what I can do then is I can identify a single landslide that I've identified in QGIS with all my imagery. And then I'll take the location, the coordinates of that landslide. I'll go back into Explorer. And then I'll just basically take images on like either side. So for example, let's say I know a landslide occurred in the month of October based on my imagery, but I don't know when in October. Then I could, see images from September and then see images from November and then like narrow it down even more and more. So then I could hopefully get it to about a week where I know that the landslide occurred. I'll also, after I've narrowed down the timing for every landslide, every layer of landslides that I've identified, I'll create an attribute table, which is basically just like an Excel kind of data table, but it's in QGIS. And in there, I'll have the time frame that I've identified, the coordinates of an initiation point, which is basically just like the start of the landslide. And then you can also calculate the area of each landslide. If you're more of a visual person, you can see here in the second row of images that are dark green. This is kind of the identification process. So in QGIS, so on the left, I have part of a satellite image, and I can see that a landslide has occurred there, just based off of the shape and the fact that it's ending into water. Most of the landslides that I've identified are really narrow. That's a pretty typical shape for a landslide. So first, I'll ensure that the landslide has not been identified in a previous year, and then I'll outline the landslide in QGIS using just my cursor, and then I'll add an initiation point as well. And so I'll repeat that for every landslide I see. And then this is the image below, figure 4, is the attribute table of each layer of identified landslides. So it includes the calculated area, the date, first and last seen, and the coordinates of the initiation point. So after I went through and I identified all of the landslides from 2009 to 2022, I was able to create this very simple graph so far of the number of landslides I've identified in each year interval. And as you can see, well, there's a few things that we can see. The greatest number of landslides in a single year interval occurred between the fall of 2020 and the fall of 2021. There are about 175 landslides. And from that, we can look at preliminary precipitation data that indicates that there were high levels of precipitation during the fall/winter of 2020 and 2021. And so we know that there's going to be a lot of landslides that were triggered and that occurred during that time period because there was a lot more precipitation, which means that there was just like more more water in the soil, which triggers landslides. We also know that between the fall of 2016 and 2020, there were on average about 18 landslides per year. And that was kind of a low period. As you can see, like in 2016, we have 23 landslides. And then in the 2019-2020 interval, we have 19. So that was kind of a short period. And then between the fall of 2013 and the fall of 2015, there were a lot more landslides, probably on average closer to 90. So patterns like that are just useful to see kind of how the distribution of landslides is happening. But it doesn't necessarily tell us, narrow down how, like in what dates or in what week intervals these landslides are occurring. So that is what I completed this past summer. I also worked in the field for 2 weeks in Alaska, looking at landslides and trying to determine how my information that I had collected from satellite images compared to what I was seeing in the field. But now in this next year, this is also my honors college thesis. I have a lot more work to do on it. So the first kind of step is to combine the information from the catalog that I've created with all of the times and the narrowed down timing intervals, combining that with modeled hourly precipitation data to determine the precipitation levels that trigger landslides. So before, with the USFS Tongass National Forest landslide inventory, we weren't able to determine how much precipitation was triggering these landslides because we only had them in really large time intervals, anywhere from, like a year to 10 years. So we weren't really able to understand at all what timing these landslides might have occurred in. And if we now understand what week that these landslides are occurring in, we can then look at when the largest storm was closest to that landslide to hopefully create some thresholds of when or what amount of precipitation triggers these landslides. We can also determine the relationship between the degree of slope and the presence of landslides. So there's a lot of topographic data that's out there that tells us how steep different slopes are, and we can relate that to whether or not landslides are occurring on those slopes. We can also determine how close landslides occur to bodies of water, such as lakes, oceans, and rivers, as well as to roads and to homes, because that really goes back to determining, how these landslides affect people. If landslides are crossing roads, that means that people might not have access to supplies, or they're trapped in their homes. So those are like the really kind of important like impacts on people on what landslides can do. And I guess kind of the really overall goal, like I said, is to determine the rainfall event threshold that has caused landslide triggering on Prince of Wales from 2009 to present day. Because with that, we could then predict future conditions that could cause landslides. So we have a lot of modeled hourly precipitation data, but there's also a lot of sensors that are in hill slopes and in the ground on Prince of Wales, where we get like, real-time precipitation data. And so if we determine the rainfall event threshold that has caused landslide triggering on Prince of Wales using these satellite images and these in the modeled precipitation data, then we can have a better understanding of in real time what amount of precipitation could possibly cause landslides, so that people can be more informed and receive warnings so that they know how to better react in case a landslide is likely to occur. Thank you.